Alright, this video is for naming polyatomic ions. We have the way of going from chemical formula to name, or going from name to chemical formula. So I'm going to start with going from chemical formula to name. Alright, so we have FeNO3, 3. So first thing we have to figure out is what are we actually dealing with? Well, good thing is Fe is on the periodic table, so we know Fe is iron. We know that iron is a transitional metal based on where it's at, so we know it will have the parentheses to say it has some given charge. NO3, luckily for us, is on our list of polyatomics, so its name is nitrate, and we know that. Now we gotta figure out what's going inside this parentheses, because iron nitrate, that'd be far too easy. So now looking up here, we know that the charge of nitrate is -1. That means the charge of this whole compound is a -1 charge. Now, we have two different 3's out here. This 3 right here has no more importance to our equation. It's completely pointless. Its only point was to give us the name of nitrate. This 3 right here, however, is key to figuring out what this number in here is. This says that we have 3 of these nitrate compounds. So it means 3 of this -1 charge, which means we have a total charge of -3. What has to be true with this compound, since there was no charge in it, these charges have to equal 0 in the end, meaning the charge of iron and the charge of nitrate have to add up to be 0. Since nitrate has a -3 charge, because we have 3 of them with that -1 charge, that means iron's charge in this equation has to be a +3, because that makes 3 minus 3 is 0. Beautiful. This little number right here tells us what goes right here in these parentheses. Since that is a +3, or really just since it's 3, we have a 3 right here, and the name of that compound is iron 3 nitrate. So that's how you name from compound to name. Now, going from chemical name, or the name to the chemical compound, a little bit harder, but not all that much. We have two things. We have aluminum, so we look at the periodic table, we realize aluminum is Al, and sulfate, luckily polyatomic again, so SO4. Now, just like we did over here where these charges had to equal 0, same thing is true over here. We know sulfate has a -2 charge. It always does. Aluminum, we look at the periodic table, and it has a +3 charge. Alright, so we got a +3 right here, and we got a -2 right here. Kind of a problem, not adding up to 0 right now. That means we're going to have to figure out what we're multiplying by. The easiest thing to do is to just multiply these two together when they're odd numbers. If it was a 4 and a 2, that'd be easy because 2 times 2 is equal to 4. So we'd just leave this one as a 1 and that one as a 2, and we'd be done. However, we're not that way. So we got to figure out what 3 and 2 both go into. And obviously our answer is 6. They both can become 6. So now we got to figure out what it's going to be named. Aluminum, what times 3 gives you 6? The answer is 2. So we put a 2. Now, before I wrote that 2, I did draw these two parentheses around SO4. The reason why you needed those two parentheses is because this is a compound, meaning you have to have however many of this entire compound, not just of oxygen, not just of sulfur, but of the entire thing. So again, we need to be 6, we're at 2. What times 2 gives you 6? Well, 3. So our actual answer will be Al2SO4, parentheses around it, 3. And that would be our name. If you look at the charges again, aluminum has that +3 charge, adds up to be 6, -2, -6 equals 0, which means we did it right. So that is the name of that compound, or that's the chemical structure of that compound. So those are the two ways that you do naming of polyatomic ions, depending on what it is. You either start with the charges, and based on the charge tells you what the Roman numeral is, or you figure out their charges, you balance them so that it's nicer. So if we would have done like sodium chloride, yes, I know, my favorite one in the world, I'm so happy. Sodium has a +1 charge, chlorine has a -1 charge. So since those charges are already equal to each other, the name is simply NaCl, no numbers required. So that's naming polyatomic compounds in its simplicity.